Cray YMP C90 Refrigeration. This video details the refrigeration system for the Cray YMP C90 computer system. There are 3 sections to this videotape. Section 1 details the refrigeration condensing units, or RCUs, that can be configured with the Cray YMP C90 computer system. Section 2 details the 2 types of heat exchanger units, or HEUs, that can be configured with the system. And Section 3 describes the operation of the RCU and HEU controllers. Now Section 1, RCUs. There are 2 types of refrigeration systems that work together to remove heat from the computer system: a dielectric coolant system and an evaporative refrigerant system. The HEUs circulate the dielectric coolant through the modules and power supply plates. This liquid absorbs heat as it passes through the modules and the power supply plates, and then is carried back to the HEU, where the heat is removed in the heat exchanger subassembly by the evaporative refrigerant. The HEU is detailed in Section 2. The number of RCUs that the C90 system can be configured with depends upon the customer-supplied power source. Sites that have a 60 Hz power source are configured with an RCU 5A, which provides cooling for the mainframe and iOS SSD. Sites that have a 50 Hz power source are configured with an RCU 5A and an RCU 6. The RCU 5A provides cooling for the mainframe, while the RCU 6 provides cooling for the iOS SSD. We will now take a walk-around tour of an RCU 5A and an RCU 6 and show you the components and their locations. The RCU 5A consists of the following refrigeration components: condenser receiver, water regulating valve, liquid lined sight glass, liquid line filter dryer, liquid line shutoff valve, suction accumulator, replaceable suction line filter, suction line service valve, compressor unloader solenoid valve. Note: each compressor has 3 heads, 2 of which are capable of being unloaded. Water flow transducer, TRC controller, high-low pressure mechanical backups, oil pressure controls. The RCU 6 consists of the following refrigeration components: condenser receiver, water regulating valve, liquid lined sight glass, liquid lined filter dryer, liquid line shutoff valve, unloader solenoid valve. Note: each compressor has 2 heads, one of which may be unloaded. Suction accumulator, non-replaceable suction filter, compressor service valve, suction. Capacity control switch. Oil control switch. Oil sight glass. The operator panel. High-low control. Discharge pressure gauges. Suction pressure gauge. Now, Section 2, HEUs. Dielectric coolant absorbs the heat in the mainframe and in the input-output subsystem and SSD solid-state storage device, or iOS SSD-E. Evaporative refrigerant removes the heat from the dielectric coolant in the heat exchanger subassembly within the HEU. Two models of HEUs are used within the C90 computer system. They are the HEU C90 and the HEU ES. Let's look first at the HEU C90. The HEU C90 is configured with the mainframe and is used to remove heat generated by the mainframe electronic components. We will now take a look at the components and their locations in the HEU C90. Dielectric coolant pump. High pressure sensor. Two HEU evaporators. Dielectric coolant strainers. Storage reservoir. Evaporator pressure regulating valves, or EPR valves. HEU C90 controller. Suction manifold. Suction line temperature and pressure sensors. Bleeder vent. Bleeder vent from mainframe. Liquid line manifold. Liquid line filter. Liquid line temperature sensor. Liquid line solenoid valve. Butterfly valve micro switch assembly. Pump up, pump down, pump. During the pump down procedure, the pump up, pump down pump forces air into the system through the air vent line, which pushes dielectric coolant into the reservoir of the HEU. During the pump up procedure, the dielectric coolant pump forces the coolant back into the mainframe. To understand how dielectric coolant flows through the mainframe, let's take a look at a graphic representation of the flow. Dielectric coolant removes heat generated by the power supply plates and logic modules. The coolant travels from the HEU C90 through hoses located under the computer room floor and enters the system at the back of the chassis. Here it flows to the supply manifold in the center of the chassis. The coolant then flows to the module and power supply plates, and from there flows to the return manifold and back to the HEU C90. Now let's take a look at the HEU ES. The HEU ES is configured with the iOS SSD-E and is used to remove heat generated by the iOS SSD-E electronic components. We will now take a look at the components and their locations within the HEU ES. Dielectric coolant pump, high pressure sensors, one HEU evaporator, expansion valve, electronic temperature control system, dielectric coolant strainer, a reservoir, for more information on the RCU and HEU components and their functions, refer to the Cray YMP C90 Power Distribution and Refrigeration Manual, publication number CMM 0506 000. Now, Section 3, Controller Operation. In this section, we will give you a brief overview of how to operate the two controllers used with the refrigeration systems. They are the HEU controller and the TRC controller. Note, the TRC controller is sometimes referred to as a refrigeration maintenance controller, or RMC. These terms can be used interchangeably. The TRC controller consists of a display panel, a keypad, a 16 AI input board, and one 8RO output board. The TRC controller is only used on the RCU5A. The display panel provides information about system compressor status and the controller operation. You can find the following information on the display panel: current suction pressure, suction pressure set point, time alarm field, operational stage identification, operational stage status, current discharge pressure, user prompt field, and installed software revision level. The controller has a number of menus that display operational set points and current values. When you power on the controller and enter the password, the main menu appears. You can choose submenus from here. The submenus available are pressure control, condenser control, sensor control, status, configuration, graphs, and alarms. Alarms can be viewed from the main menu by pressing 9 on the keypad. If an alarm has been triggered, the time and alarm field blink alternately. Each screen display has a bar at the bottom that displays user prompts. Follow the instructions in this bar when using the TRC controller. The TRC comes with operational parameters programmed in memory. To view or change set points, log into the controller and go to the main menu. Press 1, which is pressure control. Then press 6, which is the pressure set points. Now we'll take a look at the HEU controller. The HEU controller monitors the HEU C90 for any warning or fault conditions. If an out-of-range condition exists, the HEU C90 controller displays a high or low fault or warning signal on the display panel and sends a warning or fault signal to the wax. The wax indicates whether any fault or warning condition exists for the HEU C90. The HEU C90 display panel displays the monitored condition and value and enables you to check the status of monitored conditions. The display panel has two display fields, channel and value. The channel field displays the channel number and the corresponding monitored value is displayed in the value field. If a warning or fault condition exists, the corresponding LED under Warn or Fault illuminates. The display panel also has three switches: Channel Advance, Memory Display, and Memory Reset. Channel Advance increments the illuminated channel number by 1 when pressed. This enables you to check the status of any monitored conditions. Memory Display enables you to view any warning or fault conditions while still displaying current values. When depressed, this switch displays any warning or fault channel numbers and the present values in the channel and value field displays. Memory Reset erases any warning or fault information from memory. The display panel also has status LEDs for the following conditions: Main pump on, pump from reservoir, pump to reservoir, fill system, empty system, and hand valve open. If one of these conditions exists, the appropriate LED will illuminate. For more information on monitored conditions and their limits, refer to the Cray YMP C90 Power Distribution and Refrigeration Manual. This video has given you an overview of the Cray YMP C90 refrigeration system. We hope you have a better understanding of the components and their locations and how to operate the refrigeration controllers. If you have further questions, please refer to the Cray YMP C90 Power Distribution and Refrigeration Manual, publication number CMM 0506000.